Welcome to Walkabout the Galaxy, the unconventional astronomy podcast where the science is universal, the opinions are personal, and the sponsor is pseudo-theological.
Awesome.
We are Strange, Charm, and Truth.
All right.
It's a new era.
The astroquarks, also known as Josh Caldwell, Addie Dove, and Jim Cooney, coming to you from the Walkabout Studios.
It still says top quirk on my card, though.
Burn them.
All right.
Burn them.
All right. Getting new ones.
Where are we? The Walkabout Studios at the University of Central Florida. Truth, a.k.a. Jim Cooney.
Yes.
But I think we're going to leave Zoe as bottom.
Sure.
Oh.
No.
Ouch.
Original series Klingons,
Mm-hmm.
next-gen Klingons, or Discovery Klingons. Do you even know what any of them look like?
I think I know what they all look like. I've never seen an episode of Discovery, but I've seen the Klingons from it because it was a big controversy.
We had a big discussion
we
about it
discussed
here
that.
on the podcast.
Given that I grew up with the Next Generation, I'm going to go with the Next Generation ones because they're nice, they're distinctive, but not outrageous.
And you just need to, like, trim your beard up a little bit, a little bit of eyebrow makeup, and you're good to
I'm
go.
there?
Like a funky tunic.
That's not really a ringing endorsement of my looks.
No, it's not.
Ouch.
You just said that you were going to go for the original series Klingons.
No, I said the Next Generation Klingons.
That was a internal Freudian screw
You
up.
answered the wrong thing, so he just ignored it.
I'm just automatically assuming original series.
I also had a giant crush on the Klingon that Worf liked. Remember her? What the heck was her name?
She was half K-Layer? No.
Something.
You're talking about the one that he had a kid with?
Yes.
His baby mama?
Yeah, his baby mama.
She was half human.
She was half human,
K-Layer.
which made her a little bit less harsh,
K apostrophe.
but she was really pretty, and I
EH.
had a crush on her in those days.
Oh, really? How about from the movies, Lursa and B'Etor?
Oh, yeah. They're
Dude,
still very intimidating, though.
Yeah,
They were
mean.
They were super mean.
They were mean, but they were also a little bit sexualized.
A little bit.
Yeah,
Klingons.
no, they did. You did see a lot
bit.
of cleavage in of those ladies, but no, I'm not going for that.
Addie, DC Universe or Marvel Universe?
Oh, that's a tough one. So, I've always used to like DC, I think, more. And I still really like the story. I still really like the DC heroes.
Who's your favorite hero?
The movies recently have been so great.
Yeah. Who's your number one DC hero?
I don't know.
It's not Superman.
Why not?
I don't know. I'm just guessing.
He's the original. He's the OG.
Yeah.
I mean, but I like Superman because he's an alien, and that's kind of cool, right?
Uh-huh.
And then Batman was super sweet because it's like he's just a dude that's
That's
got
right.
a lot of really cool toys.
Yes.
Which I do like.
I used-
And the Lego Batman movie, pretty phenomenal.
Yeah.
So, but I really like all of the Marvel adventures these days. So, but I didn't read comics growing up either. So,
Okay. Well, we're going to come back to DC and Marvel in our trivia.
ooh,
Just to
okay.
give you
I
a
did
little-
finally see Infinity War though.
How do those things pseudo-theological? Anyway, I guess we'll find out.
No, the sponsor is.
sponsor
Oh,
is
the sponsor.
pseudo-theological.
Get your podcast together, Jim.
All right.
Yes.
I'm with you. Sorry.
Man. Today we're going to talk about, guess what?
Water on Mars.
How did you guess?
It's just, I don't know. I just could feel it today.
There's just this feeling. It's because it's an even numbered day. I don't even
I
know if
almost
that's
said
true. It's
water
not.
on the moon.
Also, maybe a little bit.
Whoa.
Yeah.
Yeah.
Crazy.
So some speculation about early habitable period on the moon. Another water on Mars story. This one, we'll give it some time because it's talking about potentially liquid water on Mars now,
Yes.
as opposed to ice or liquid Mars water in the past. We got a little bit of GR black hole news from Truth Quark over there. He's
Sweet.
just relishing in his new moniker. Just announced today the first
Hot off the presses.
the first commercial crew astronauts, NASA astronauts that will fly on SpaceX's Crew Dragon crew
And the Boeing Starliner.
and the Boeing Starliner. They're talking about 2019.
Yeah,
This
Boeing's
news makes
not
me
going to make
sad
it. Why?
because Addie Dove is not on that list.
Well, there's
Josh
no
Caldwell's
chance of
not
me
on
being
the
on
list
that
either.
list.
Yeah, but Addie's always really wanted.
But they selected these
Josh
from
Caldwell's wanted for longer, just saying.
Josh Caldwell, his
He
time
doesn't talk
has
about
passed.
it as much, though.
I've given up.
Yeah.
Well, actually, no, because like the astronauts that were chosen are all Josh Caldwell's age.
For real?
But they've been astronauts for like 10 years.
Yeah, well,
or more.
longer than that for most of them. Yeah,
Some of them not.
there's a couple of
There's
newbies,
a couple of newbies, yeah.
but most of them are veteran anyway.
So they were introduced today by NASA's new administrator, Jim Bridenstine, and through an adoring crowd. So they will be the first NASA astronauts to fly from a U.S. launch point on a U.S.-built rocket since when?
Space Shuttle.
Which was when? The last Space Shuttle mission? Got the first 2 digits right.
11.
Very good.
Thank you.
Bing,
Nice.
bing, 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 bing.
You know
That's
how
not
I know that?
because you know it.
Yeah, mostly.
Yeah.
Mostly just because I know it. Also, it's
'Cause
because
you
it
were
was
there.
right before I got here.
Oh, yeah. I didn't go down for that launch, but I was in a meeting with Alan Stern, who was here, and we all sort of just rushed outside and climbed up the stairs by the engineering building here at UCF, and we saw it go. And that was a little bit, it was bittersweet or heartbreaking or whatever the appropriate sort of schmaltzy word is to throw in there, because I saw the first shuttle take off from Titusville.
Pretty crazy.
And then saw some experiments go on it. But
Yay.
shuttle era, so it's been a long time.
It has.
It was longer than I thought it would take for SpaceX
people.
and those guys to get
Longer than most people thought it would take.
Yeah.
But they were supposed to announce this earlier, but they delayed it because Boeing recently, like last week, put out an announcement that they are delayed.
And that's so weird because like launch delays never happen.
I know.
It's just not a
It's
thing
just
that ever
not-
happens.
It's a surprise. Yeah, they've been having an issue with some of their tests they did, so they're actually pushed back. So now it currently looks like SpaceX will be ready first. But they're still sort of in a leapfrog kind of thing.
So the SpaceX Crew Dragon, that's what it's called, by the way, Crew Dragon.
It's just Crew Dragon.
That is looks conceptually, it's very similar to the old-fashioned Apollo capsule and also the Orion capsule. It's a capsule. It's a gumdrop.
It looks like Cargo Dragon.
It does.
Yeah.
It's a gumdrop.
It's also a gumdrop.
Thing that goes on top and it comes back under parachutes for a splashdown, right?
So is the CST-100 Starliner.
Oh, is it?
Boeing.
Okay, it's not a space planey type thing.
No, it's also a capsule. Both of them are capsules.
I thought the Starliner. I guess I was thinking of Sierra Nevadas.
You're thinking of the Dream Chaser.
The Dream Chaser, not the Starliner.
Yeah.
Okay. So the Dream Chaser is a different one that looks like a mini space shuttle.
It does.
That gets
They
stuck
recently got refunded also, and they are supposed to be doing some tests out at Kennedy at the landing facility at some point.
So all sorts of exciting things going on with launches. Recently we had a new test flight of the Virgin Galactic
Spaceship
2, and it went up halfway to the artificial line of space called the Kármán line, 100 kilometers above the surface. Went up about half that distance. What's half of 100?
50?
Right. And we've got a payload going up on that soon
Hopefully.
to space.
So what
hopefully
fraction
soon.
of the Earth's atmospheric mass is below that?
It's an exponential, so you gotta...
Most of
I don't
it.
know, most of it.
The
Good answer.
overwhelming majority of it.
More than half.
Yeah.
Yeah, the last flight was pretty cool to watch. They had recordings of the pilots being like, oh, it's so magnificent. Because they were high enough that they could see curvature.
Right. And their sky was...
Yeah, I know.
BS. Not according to my model.
Oh, that's right. Jim doesn't believe it.
The sky is dark up there too.
Yeah.
So up.
That's because it was at night, Josh. It wasn't. It was during the
That's
day.
because it was above most of the atmosphere.
Yeah.
Yep.
Yeah. So that's exciting. That's going on. We're also
And Virgin also recently announced that they're going to start building operations in
a little town in Italy.
a little ceramics town in Italy.
Yeah. That happens to have a ginormous runway.
Yeah.
And it's far away from other air traffic, so it's a good place to launch things from. And so Virgin Spaceship 2 is going to be a tourist rocket,
Yes.
primarily. We're going to be flying
We're going to sneak some science
payloads on it, but the business model, I think, is overwhelmingly that it'll be tourists going for a joyride in space. And their first flights are from the Spaceport America in New Mexico with tourists. And when you go up 61 miles or 62 miles above the surface of the Earth, you see a little bit of curvature, you have a black sky, you're free floating for a few minutes in free fall. That's cool. Come down, get your astronaut wings. But what's your view? Your view is not of the whole planet. It's not like going to the moon or even going to the ISS. You have a pretty limited view of how much of the planet you can see.
Right.
And so it kind of matters where you go from.
Yeah.
Like if I'm a space tourist, Do I want to be touristing
Over
over
the desert?
New Mexico? Or maybe over the boot of Italy?
Yeah.
Yeah.
Or the penis of Florida?
Florida is the penis of the United States.
Anyway. But first.
But yeah. And they also could potentially then do flights between Italy and other places in the U.S. at some point.
At some point down the road, they're talking about if
Doing,
we
like,
sort of
high-speed
get
travel.
true space plane type stuff going. Yeah. So they're looking at
Like an
another
hour to
spaceport
get back and
there
forth instead of much longer.
instead of 8 hours.
Yeah.
There would still be 2
just have
hours
to
to
be
get
at, like,
through customs.
6G, though.
That'd be a little bit rough. But first, this episode of Walkabout the Galaxy, Jim,
Okay.
is brought to you by the Oh My God particle. Do you know about the Oh My God particle?
Is it oxygen
Not yet.
and magnesium?
I think I'm about to learn about
It's
it.
an
Is it
individual
oxygen
particle.
and magnesium?
It's not, but that's a very good.
I saw that joke recently and laughed a lot.
That's awesome.
Because normally that compound is written MgO, but you can write it. You can write it OMG.
But it would be a big O, a big M, and a little G.
Well,
that
yeah.
would piss some people off.
It would.
The Oh My God particle, a Tesla in ludicrous mode, may get you from 0 to 60 in 2.8 seconds. But
What?
this cosmic ray, detected in 1991, has the particle speed record at 99.9999999999999999999999999999999999999999999999999999999999999999999999999999999 of the speed of light. And that was 21 nines after the decimal point for those keeping count.
Wow.
Yeah, that's right.
OMG.
A proton traveling so fast that a beam of light would take more than 200,000 years to gain 1 centimeter edge in front of it in the frame of an outside observer.
Right.
But in the frame of that particle, the speed of that photon is going the
It's
speed
going
of
to pass
light
it
away
at the
from
speed
it.
of light. Right.
Mind blown
Mind blown.
by the Oh My God particle. That's right. Its relativistic speed increased its mass by more than 300 billion times,
Wow.
giving this
You'd think you'd slow
subatomic
down.
particle the same energy as a baseball hurled by the strange astroquark, which is to
Wow.
say a fairly slow fastball. So keep your eyes open on your Walkabout the Galaxy for the Oh My God particle zipping by or through you. It's got places to go and things to smash into.
Wow.
Neat.
That's pretty cool. That's
Neat.
a fun sponsor.
That was a lot of nines.
That was a lot of nines.
2 before and 21 after.
It wouldn't have been as good a comparison if it was a baseball thrown by the Charm Astroquark, which is why.
Which would have been,
is why it was
it's
a strange.
nowhere near that much energy.
Not quite.
The Charm Astroquark baseball is definitely a much more energetic baseball than the strange Astroquark baseball.
Sure.
I'm weirded out by the 5-1 at the end of your list of nines. Seems like
unbelievable
unbelievably.
precision.
Yes, it does.
But I don't think it is really because you're not measuring that. Right?
No,
you're
you're not
measuring
measuring
the
the
energy.
speed, or the,
Right.
yeah, the energy.
Right. And so you measure the energy, and the energy corresponds to a Lorentz factor, which is how much relativistically did its mass change.
Right.
And that you then just plug into some equation, and it gives you a speed.
Yeah,
So
but are you really measuring? But that speed, so you're measuring this v over c, right? Where the velocity of the thing divided by the speed of light.
Are you speaking truth to power?
And the speed of light is known. I don't even know if the speed of light is known to that many digits.
It is not, probably.
And so how do you? I don't know. There's something fishy here.
I don't know. I think you just like fish.
I do also like fish.
Yeah. Okay, we'll check into it.
Yeah.
But I don't think it's certainly true that the way I read it, it implies 23 or 5 digits
Right.
of accuracy, which is certainly not the case of the measurement.
Of course.
The measurement was like 2 significant figures, which is what's the energy of this thing.
Right.
And then I say, I know it's a proton,
Right.
right? Then you get some like, okay,
Sure.
what number do I have to put in there for V over C
Right.
to make that happen?
Right.
Where V is its velocity, and we've gone off the deep end.
Yep.
I'm getting the Addy
My
look that
apologies.
says you guys have gone off
Yeah.
the deep end.
Yeah. Nobody cares about that kind of thing.
Yeah,
Well, no, we care about that kind of precision.
Strange and truth.
you're going back to top after that.
Oh, no!
Dang. Nah, Top's cool. I picked Top. So I
You
think
did.
Top's cool, but
But recently, you
then
were
I felt really
having-
bad because then I realized that means Zoe's gonna have to be bottom, and that bottom's not his coolest beauty, and
Yeah.
so
Maybe we should just leave you top. We changed her to beauty. We don't need to mess
Sounds
with the top.
perfect.
yeah.
Okay.
All right.
Well,
Anyway.
water on Mars.
Onward.
Water on what?
Water on Mars.
Yeah. So tell us about the new measurement.
Me?
Yes.
Okay. It's almost like...
It's not like all these years we've been orbiting Mars and there was this lake that escaped our notice. It's like all of a sudden it's like, hey, wait a minute.
We didn't look in that one spot.
Look there. There's a
whole time.
lake. Yeah.
No, but it sort of is because, but the lake is a subsurface lake.
Yes.
It's buried by lots of other water, but it's frozen water.
Right.
Right.
This is
Yeah, so
underneath
this
the
is
polar cap.
Yeah, so this is a lake that they found underneath one of the southern polar layered deposits. So they're called the polar layered deposits because there's like these layers of ice and dust that get put down over time, and it actually recedes and gets bigger and over time.
Mars has really extreme seasons, and so in southern summer, a lot of the southern polar cap evaporates straight into the atmosphere. The atmospheric pressure goes up significantly, and then in the winter it condenses out, so that's what gives you those layers.
Yeah, and so Mars's tilt is similar to the Earth's. It's a little bit bigger, right?
It's about the same.
Very similar.
25
It's-
degrees.
So, yeah,
Something like that.
surprisingly similar.
Within a couple degrees of our axis tilt,
but it
but
has,
they have a longer year, which means that
well, they also have a much larger eccentricity.
and a
Yes.
big eccentricity.
Do not.
No,
You're definitely
larger-
demoted to top. How dare
Demoted.
you? How dare you say that?
dang it.
It does
wasn't
have a
it?
larger eccentricity.
It does.
And also, but its length of the day is similar to ours, and its
Yeah.
seasonal, like its
Is
tilt.
it? It's a half hour longer.
It's 26 hours, I think. Or is it
It's
25
just
hours?
it's just a half hour
Oh, is it? I thought it
difference.
was
35 minutes, something like that.
Yeah.
But yeah, the eccentricity, just to remind our listeners, is how egg-shaped the orbit is. So Earth is actually closest to the sun by a smidge. That's one of the new astronomical units. Earth is closer to the sun by a smidge in January,
Right.
but it's the tilt that is dominating the seasonal effect. For Mars, it changes its distance by like 500 smidges because of the egg-shapedness of its orbit. So it's
smidge, new official
it's
measurement.
10% closer or so to the sun at one time at one time of its year than another. And if you happen to be on the hemisphere facing the sun at that time, you got a really hot summer.
Right.
So in these layer deposits, so we've been looking at these layer deposits for a long time. We have lots of optical images, but we also have lots of radar images. And so the MARSIS instrument, Mars Advanced Radar for Subsurface and Ionosphere Sounding,
Whoa.
Nice.
yeah, is used to look at radar on the polar caps. And it's crazy. So have you guys ever looked at radar observations from
I've
these
looked
instruments?
at radar from Cassini.
What?
Yeah.
Nice. So the crazy thing about, and so we've talked about like radar sometimes from asteroids, right? So from Arecibo.
Oh, yeah.
So the thing that always trips my brain is that when you get radar measurements, you have this like thing that looks like a map of subsurface layers, right? Because it's like a radar and it's showing you these layers in a structure with like a
Yeah.
location on the surface. But it's actually time. Is what they
Right.
plot. They plot how long
It's
it takes for that
confusing.
signal to return. And so it's not actually like necessarily an actual physical
It
distance.
looks like a picture, but it's not a real picture.
Yeah.
Because the beauty of the radar is it goes into the surface.
Mm-hmm.
So you're able to see below the surface, unlike with regular cameras.
Yeah.
And the way they get how deep you're looking at is because we're sending a beam of light that is like a tuned radio wave
Mm-hmm.
that we can tell when we see an echo back. It's like, oh, that's the echo from the radio wave I sent 5 jiffies ago. And it took me exactly this long to get back here. So I know exactly how far it traveled. So I know
Yeah.
exactly how far deep into the surface it was.
Yeah, but then they also have to. So for these though, it's complicated. It's more complicated than that.
What?
Because it's traveling through ice and dirt and stuff that has a different time
index of refraction.
and also
that
different
changes the time.
travel in the different types of materials.
Yeah.
So a really bright reflection on these is either off in the surface. You usually get a really strong surface reflection,
Yeah.
but then something further down, if you get a really bright reflection, that often means like liquid water or
Right.
something like that. Because
Yeah.
ice has a different allows light these radar wavelengths to propagate through better than liquid water.
So when they see water,
Mm-hmm.
really what they're seeing is a different kind of interaction with radio waves
Mm-hmm.
from something.
Right. Basically means some kind of discontinuity and a smooth surface of some kind. This is how
Yeah.
this is how they found the lakes on Titan as well, right?
Yeah, but those actually are on the surface.
Right, those are on the surface, but but we had to penetrate through the clouds and whatnot on
Right.
Titan because you can't see through.
Yes.
Here, the thing that's blocking our view is solid,
What
which is ice.
what
and
did
dust.
they use to find the lakes on Titan?
Cassini.
Cassini.
Oh, yes, Cassini.
He's not prepared for that, like Josh always is. Yeah, so like previously we've gotten really interesting data from this instrument to like see what the different layers structure kind of looks like, and you can tell that like some things are maybe dirtier and some things are icier. But this time they're pretty sure they found liquid water.
And
So this is interesting. Why?
Ooh!
Because it's the
Go
first
for it.
time that we've kind of found liquid water currently on Mars, right?
Right.
So not on its surface, but somewhere.
And it's
on Mars.
probably like a lake of some significant size. They said maybe like 20 kilometers or
Right.
something.
Some big.
And so why, of course, the reason we don't see liquid water just hanging out on the surface of Mars is because A, it's very cold.
Too cold. And B,
the low pressure.
There's no atmosphere to speak of,
Yeah.
so it just wants to evaporate.
It basically goes from a solid to a gas.
A gas.
It sublimates.
It doesn't like to be a liquid. But so underwater, underground, this thing is still actually quite cold. It doesn't have the evaporation problem, but it still has a temperature problem.
But
And
it's under higher pressure.
nevertheless, it's not enough.
Persisted.
They think that in order for it to, you have to lower the melting point for
Yeah.
this to be liquid. So this is probably a
Salty.
stinky, salty sea.
right.
That's not something you just go up to and scoop a cup out and take a swig.
Right.
Oh, you could.
It's worth noting we have very similar things on Earth. So we have some lakes that we're aware of beneath kilometers of ice in Antarctica.
Also at the southern pole.
I don't know about kilometers, but certainly at
It's
least
kilometers.
Kilometers.
So the biggest and most famous is Lake Vostok, which is near one of the big Russian stations down there.
what a
And
coincidence!
is-
What a coincidence for
Is
those
4
guys.
kilometers under the surface, which is very, very deep. They've actually drilled a borehole down to the lake.
Okay.
Or
Yeah.
several of those things.
Several times. Yeah, they did it. Like in the
And
last
what did
couple
they
years,
find
yeah.
in the water besides salts,
So they may have found microbes.
organisms, critters?
You know, there's a lot of controversy about that because the drill itself is not necessarily sterile,
Sanitized.
and the stuff that the liquid, you have to put liquid down into the borehole to keep it from refreezing and that stuff. Anyway, so it's not entirely clear that the things they found in the ice samples from just above the lake or from the water are actually from the water, but they might be,
Right.
which is intriguing.
So the astrobiologists are very excited about this.
Right, so
Yeah.
this discovery.
Liquid
And
water
that's
Mars.
also-
If life ever existed on Mars, it may still hold on in
these
places like
areas.
these under cap lakes.
A lot of astrobiologists study things like Antarctica and like Vostok because it's where extreme environments where you can have things live, and that's why people also get excited about like water in Europa or Enceladus because
Right.
maybe you have life there.
So now there's several bodies now that we know of with subterranean
Subsurface, yeah.
liquid water. Water itself, I mean, the molecule is pretty abundant. Hydrogen is very abundant. Oxygen is very abundant in the universe. So it's not surprising to find the water molecule, but finding that nice liquid state is a big deal. Yeah.
One of the things about these measurements too is that like, all right, we've been looking at Mars Express has been up there for like, I don't know, 15 years or something. It's been a really long
Right.
time, right? So why do we just find it now? It said that they've been looking for a long time, but their resolution wasn't enough, so they couldn't really see small enough spots on the surface because radar is sort of tricky. You're moving as you're taking the data with all of these measurements, and so they get pretty big swaths of land. So they had to like actually change their measurement technique in order to get these measurements.
Right. Because it's a good sized lake for a swim, but for observing it with radar from orbit, it's a little bit on the smaller side.
Yeah, I don't know what the typical resolution of.
Yeah. But like you say, you've got a
was.
big spot that you're shining down from a spacecraft that's zipping by, and you've got to pick up the signal. So it took some time to see this one. So that's cool. I wonder when we'll ever talk about water on Mars again.
I don't know. It could be
Could be next
Millennia.
episode.
Could be. Yeah.
over the next episode.
Right. Trivia today, we're going to do a little bit differently.
Oh.
Well, no, we'll do it
I'm going to ask it. Just because I don't have one today. I'll do one next time.
It's a multi-part thing.
Ooh, I like multi.
So we're going to go through it. It's going to tell you kind of what the idea is, and we'll come back and take your guesses on these things.
All right.
Okay.
So I'm going to give you a list.
I'm
We're
gonna go
testing
get
your
coffee.
superhero knowledge.
Oh, that's not good.
I'm going to give you a list of superheroes, and you just have to tell me which universe it's from. The DC universe, the Marvel universe, or the BS universe.
Okay.
Oh, all right.
All right? Everybody familiar with those universes. So here, I'm just going to go ahead and give you the list now, and then you can think about it. Then we'll come back. All right.
Okay.
And listeners, you can, I'll be curious how many people recognize some of these guys. First up, the Knight and Squire. Second, the Arabian Knight. Third, Left Winger. Fourth, Right Winger. Fifth, Richard Dragon. Sixth, Dragon Dick.
What?
Seventh, Angar the Screaming Hippie. 8, Pow Wow Smith. And finally, the Gas Man.
Why are there 9?
Though, there is
fine.
no reason.
Okay.
There is no reason. There is no significance to
Is
the
it
number.
because there are 3 of each?
Maybe.
This is going to be very challenging.
I know.
So there will be a score.
This is the hardest.
Each one of you will have a score from 0 to 9.
All right.
Okay?
All right.
All right. So, Addie can
I
wrap her
didn't hear
head around it.
Superman or
No.
No, of course
or
not.
Wolverine
Those are too
anywhere
obvious.
on those lists.
Those are
Well,
too
let's, all right.
obvious.
So let's try it out just to make sure you're at least, know better than my mom.
Yeah.
Superman, Jim.
He's a DC universe guy.
Okay.
We-
And Wolverine.
That's a Marvel universe
Okay.
guy. Okay.
So, all
okay.
right.
All right.
So we're at
Good
least,
job.
okay.
Okay.
We got that.
Those are pretty much the only ones.
And then here's
But
the
if you
third.
know- if
Here's
you
the
know
third. Here's the third
Wolverine
one
is-
for you to test is strange astroquark.
That's a BS universe.
The BS
guy.
The real universe.
Yeah.
Can we call it the real universe?
The real universe.
Yeah.
Right, okay.
Yes,
All right.
we are the real heroes.
It's true.
There was something switching gears to the sort of to the
Oh, yeah, we don't answer yet.
cosmological,
Cosmological?
relativistical. How about that?
Yeah, I like that better. Cosmological implies
Okay. Has to do with like origin of the universe.
Yeah, like the nature of the
grand
whole
scale.
universe, right?
I think of
Galactical.
anything that has to do with general relativity in my mind gets connected to cosmological.
Right, but we're interested. Of course, it plays a huge role in cosmology, but it also plays a huge role, general relativity, in black hole stuff, which is on tiny, tiny scales,
Yeah. Okay.
GPS.
and GPS,
Yeah.
which is everyday scales.
Right. Okay.
I mean, I would argue
Fine.
that any scale is an everyday scale.
Okay. What's our black hole general relativity news?
This is just more fun. So,
Okay,
general,
then never mind.
General, not more. General relativity
fun.
is a very hard theory to test, right? Because of basically
Do you know
what we
what
just
the
said.
best? Do you know what did the best test of general relativity to date? The most precise constraint on general relativity.
It was Cassini.
I bet it was Cassini.
You didn't know that?
We've talked about that
We have
before.
talked about it
Yes.
before. I don't think I would have said that it was the most
It was.
most constraining.
It was.
But
it was.
It still is?
50.
I believe you.
Yep.
And why is it so hard to get good constraints on general relativity? Because it only plays a significant role in things it only gives significantly different predictions than Newtonian physics under
Extreme crazy
conditions. And
yeah.
extreme conditions here means very high, strong gravitational fields.
Right.
And the Earth, the Sun, these things don't have very strong gravitational fields, so the effects are all very subtle and very hard to measure.
And this is, and the interesting thing is, just to get back to what Addie was saying is, then people are like, well, then why do I care?
Right,
If I could
right.
just use the nice simple GMM over R squared that Isaac Newton gave me with
Right.
an apple.
And we still
400
can,
years
under
ago.
most circumstances.
G pi
Everything's
over R,
fine.
or
Yeah.
whatever that one was.
Yeah, it's G pi R pi G T over
Oh,
R,
yeah.
something
It's
like
getting
It
that.
might have just
wronger
been
as we go
pi GT.
But actually, it does make a difference with whether or not you take the right turn when you're driving around.
That's right.
If the GPS did not have the relativistic correction in it,
You might turn 30
you would
inches too soon.
No, you would
No, it's
turn a
pretty far
whole.
off.
You would maybe take the whole wrong street.
I do that sometimes
Driving
anyway.
around.
But yeah, so it's cool that GR does finally have some everyday applications, but not a lot. For the most part, you could live your life pretty easily without any knowledge of
My
general
life was a
relativity.
disaster until general relativity and GPS came along.
So testing it is difficult. One place that'd be cool and easy to test it would be
My backyard.
the center of the Milky Way galaxy.
that's a
Why?
better
Because we
place.
have a giant
Isn't-
supermassive black hole that lives there.
Okay.
Supermassive black holes, of course, have powerful, strong gravitational fields, and so if things wander close to the supermassive black hole, they're going to be significantly affected by
General relativity.
General relativity. Or
Gravity.
their paths will be different from the paths that Newton would have predicted.
Yeah.
Because Einstein said, you're wrong, Newton.
Right.
And so, recently the ESO, which is the European Southern Observatory, down in Chile, the Very Large Telescope there, which is a cool
VLT.
name telescope. Yeah. Very large
But
telescope.
have you noticed that like all the telescopes now, it's always something like that? It's the extremely large telescope, it's the very large telescope,
The
it's the
30-meter
gigantic
telescope.
meter telescope, it's
Yeah.
the 30-meter telescope. Yeah.
The very, very large
creative.
telescope made some measurements of a star that wanders particularly close to the center of the Milky Way galaxy, and the path that it took matched the path that general relativity predicted dead on. So,
Okay.
Yay, Einstein once again.
Yay!
Okay.
That's pretty much it.
Did that star get sucked into the black hole?
It did not. It did not. It travels on a highly eccentric path near the and comes very close to the black hole every now and again, but does not get sucked in. As long as you're not too close to a black hole, you're fine.
Yeah. When you get too close, why do you, so a lot of people's like, oh, black holes, a lot of people have this image of black holes or a metaphorical image of them as sort of like these giant gravitational vacuum cleaners in
Right.
space that are like sucking things in.
Yeah.
It's not really that way, but it is true that if you do get too close, even if you weren't otherwise going to go in, you will go in.
That's right.
Because why?
Well, I mean, there are, of course, some distance away from the black hole called the short shield radius, right? Where,
But I'm saying, like, of course, if you head to it, if
Right.
you're like, okay, I'm going this way and I go in past that radius, then I'm
Right.
done. But if you're wandering by and you're too close, you can lose energy
right?
because it's a crowded area.
What? You're
You
losing
can
me.
lose energy. You
How-
can get captured into the accretion disk of the black hole.
You can. Yeah.
And then you're going to go in.
That's true.
But
Yeah.
this is outside of that.
Yeah.
Right. Yeah. Typically, what he's referring to. So you saw Interstellar.
Yes.
Oh, I was just
great
telling
movie.
my class about how great that movie was.
What an amazing drone chase through the corn
You
in that movie.
You shut up. It was a great movie. But obviously the
How about that baseball
the black hole in
game?
there has an accretion disk around it, and we've talked about how great that those images are. But that's very common. And you're right. If you get you can easily through friction lose energy if you wander too close or into the accretion disk. But as long as you stay outside of that, you're golden.
You're good.
You're golden.
good.
And actually, that doesn't extend terribly far away from the black hole. So
Right.
usually you're pretty good. Just don't go too close.
One of my things I like about this article that we're talking about, this news item we're talking about,
Yes.
is that some of the observations were made by instruments called Gravity and then Symphony.
Symphony, right?
Symphony, SINFONI.
Oh,
And then another one called NACO or something.
What does symphony stand for? I don't know.
I don't know.
I don't even know.
Go to look at that,
But
there are some. Usually, the instruments on the telescopes have
have
clever
good names.
yeah,
The telescopes themselves are a little bit lame.
It's just
Yeah.
a very large
It's
telescope.
very large.
The very large array.
How big is it? Very large.
very large.
Yeah. The other sort of astrobiological thing that popped up was just a little short sort of speculative article about whether or not early on the moon might have been quote unquote habitable.
Yeah,
Yeah. I would habit it now.
yeah.
But you'd have to pack very carefully if you were going to live on the moon right now.
Yeah, so this article
Shopping
came
choices
out.
are limited.
They are. You'd have to bring most of your stuff with you. This article came out because there was another recent article that I think we touched on at some point about how sort of revisiting the impact hypothesis for the moon and how long, like, sort of the gas and dust would have surrounded the moon after it initially
After it
formed.
formed from in the fallout of some giant impact onto the proto-Earth.
Yeah,
Right.
so it formed, and there was probably this sort of denser cloud of dust and gas that surrounded it that maybe lasted longer than we had originally thought. And so there was this article that came out a few months ago, I think, about how long that might have lasted and if there would have been sort of this lunar atmosphere
Right.
that lasted a
Long
while
enough
after
to
that.
sort of maybe have water be stable and keep temperatures
Yeah.
Right.
moderate and reasonable.
And at that time, you still have the sort of impacts probably that we had on Earth that are maybe bringing more water and more organisms or
Comets and
prebiotic
things.
things,
Yeah.
right?
Sure.
So it's potential. There's potential that very early on it was quasi-habitable.
And then another period, right? Sometime later when the interior is still active,
Burping.
volcanically outgassing, and then there might have been another brief period of atmosphere as volcanic gases formed a thick enough atmosphere to keep water on the surface for a while. So potentially two periods, neither one of them very long. So you wouldn't have you wouldn't have had any significant chance for evolution of life, but perhaps life could have evolved briefly.
Yeah.
Or survived because it already evolved on Earth.
Yeah, most of what we'd have to look at if we were to look for any signs of that on the moon would be like some probably subsurface, like old regolith that formed early on when there was this. Because you don't see any like water alteration features on the surface now, but you could look in the subsurface to see if there's like clays and other minerals that only form in the presence of water.
Right.
We're not probably going to find a subterranean water lake on the moon.
No.
Almost certainly not.
If you were packing for the moon, I think the
Yes.
only thing that you would not need to pack to bring with you is the ground. Pretty much everything else you're going to need to bring along with you.
Yeah.
The moon will provide a surface for you to walk around on,
Yeah.
and everything else is up to you.
Yeah.
You get, I mean, if you're willing to have darkness for 2 weeks in a row, then you don't need a light.
Is there enough? So there's some ice, right, on the permanently
In the South
Probably.
Polar region,
permanently
again, sort of,
permanently shadowed regions. Is there enough to collect and drink?
well, there's enough water molecules there to make yourself a nice glass of water, probably in a swimming pool, or maybe even more than that. But it's not like you can like go up there with a hammer and chisel and say, "Oh, here's my ice cube."
Yeah, most
Right.
of them are like
It's
sort of
all
intimately
mixed in.
with
Yeah.
dirt.
Right.
But there's a lot of cool ISRU possibilities for
In situ resource utilization.
for separating water from these things.
And you mentioned intimate mixtures, and
Yes.
we just think that's a boring term, but that's actually a hilarious term that is used by scientists with a straight face.
I think it's hilarious. I giggle on the inside every time I
It's an
say
intimate
it.
mixture.
When
Yeah.
Todd Bradley used to say it, I
Yeah.
used to giggle a lot.
So that's just referring to how at what sort of scale different components of dirt or something are mixed together. It's an intimate mixture.
It's intimate. They're well intertwined.
Okay, so I
Okay.
can't figure out how to segue from that, even though I feel I should. Twines to poison ivy to superheroes and villains.
Great segue.
Okay, so here you go.
Okay.
All right.
Knight and Squire. And you guys each let me know what you think, and I'm going to keep score. Knight and Squire. DC, Marvel, BS.
Okay.
DC.
Yeah, I would have gone DC on that one too.
You can.
You're
can
allowed
Okay,
to.
okay.
Arabian Knigget.
Arabian Night?
Yes.
Marvel.
You're just copying?
Yep.
Left Winger.
Marvel.
DC.
Right Winger.
BS.
BS.
Richard Dragon.
DC.
Marvel.
Dragon Dick.
BS.
BS.
But it's going to be a real one.
It's-
But Richard's short name for Richard is Dick. So
Yes.
that's
Anger
where
the
that
Screaming Hippie.
DC.
DC.
Pow Wow Smith.
Marvel.
BS.
And the Gas Man.
How many do I have of each?
I don't know. I've just kept track whether you got them right or not.
Oh, okay.
Yeah.
BS.
What is it? The Gas Man?
The Gas Man.
Marvel.
Okay. Addie wins 5-4.
Oh, you pulled it
There's
out.
the one at the end.
Five.
Gas Man.
5 and 4 is actually better than I thought either one of us
Me
would do,
too,
to be
yeah.
honest.
The Gas Man is BS.
Oh, it wasn't that at the end.
Dragon Dick is BS.
Okay.
All the others are real.
Okay.
Yeah. Including both Left Winger and Right Winger.
Oh, okay. So go through it.
Left Winger and Right Winger are villains working together to expose Captain America for some reason.
Okay.
I don't know.
Okay.
The Knight and Squire, that's not that exciting. They're sort of British Batman and Robin types DC. Both
Okay.
got that one. The Arabian Knigget's Marvel.
Okay.
Richard Dragon is a DC character as a kung fu trainer and trained some of the other DC characters. But Dick Dragon, while is real, Dragon Dick is not.
It
It's
was
BS.
too close. I knew it had to be one or the other.
Angar the Screaming Hippie is a Marvel character whose scream sends people into a catatonic state.
For some reason, I felt like that could be a thing because of the Aquaman character. I don't know.
Does he have a scream or something?
No, they just for some
Something
reason
about it.
it's-
There were some connections
yeah.
going on there, but
In
you
my
guys
head,
both
I
missed
just
that one.
did.
Yeah. Pow Wow Smith is some real thing that was a guy who he was a Native American character, DC universe, who
Yeah.
then became, worked as a policeman or something. Anyway, there's a gajillion You asked why are there
yeah,
9?
yeah.
There easily could have been 90
Yeah.
on that list of characters that I had never ever heard of.
Right.
Yeah. Anyway.
Yeah, there's always like these edge case ones that sometimes appear in the movies now, and people are so excited about them if they really know the comics.
Right.
But
Yeah. Well, anyway, hats off to Addie. 5 out of 9.
Very nice.
I did
Yes.
pretty well. I did pretty well.
Yeah. Well, you may feel like you've spent time with Angar the Screaming Hippie. It's actually just been another episode of the Walkabout the Galaxy. Be sure to like us on Facebook to get all our updates and check out our website at walkaboutthegalaxy.com, where you can also see some of our past sponsors and our new logo with swag coming soon.
Yay.
Follow us on Twitter,
At walk_the_galaxy.
where you can ask us questions and suggest topics that you'd like to hear us discuss. Our theme music was composed by Richard Drusik. Catch up on old episodes wherever you get your podcasts, and tattoo a review of us on the small of your back and head to the beach.
Nice.
I'm Josh Caldwell.
I'm Addie Dove.
I'm Jim Cooney.
We're the astroquarks, signing
us.
off until the next episode of Walkabout the Galaxy.
Bye for now.